How is factoring used in cryptography and security? Imagine trying to hide a secret by locking it behind a puzzle that is easy to create but very hard to solve. That's what factoring does in the world of digital security. Factoring involves breaking down a large number into its prime factors, which are numbers that can only be divided evenly by one and itself. This simple idea from algebra and number theory becomes a powerful tool in keeping information safe online. One of the most common ways factoring is used is in the RSA encryption system. RSA relies on the fact that multiplying two large prime numbers together is easy, but finding those original primes from their product is very difficult. When someone encrypts a message, they use a key based on this large number. To decrypt it, you need to know the original primes, which are hidden inside the product. If someone can factor that big number into its prime parts, they can unlock the message. But for very large numbers, no quick way to do this is known, which keeps the system secure. The security of RSA depends on the difficulty of factoring large numbers. Typically, these numbers are hundreds of digits long. For example, a common size for secure encryption is a number with at least 256 digits. Factoring such a number with current technology would take an enormous amount of time, making it practically impossible for hackers to crack the code. Factoring also plays a role in understanding the limits of cryptography. Researchers develop advanced algorithms like the quadratic sieve and the number field sieve to try to factor large numbers more efficiently. These algorithms help scientists see how secure current encryption methods are and guide the creation of even stronger systems. In algebra, factoring helps simplify expressions and solve equations by breaking down polynomials into smaller, manageable parts. In cryptography, this idea is extended to large numbers. When a number is factored, it reveals the building blocks of that number, which in turn helps protect digital information. The process of factoring large numbers is like a lock that is very hard to pick, making it an essential part of keeping our online lives safe. So, in simple terms, factoring is used in cryptography to create puzzles that are easy to make but very hard to solve. This difficulty forms the backbone of many encryption methods, helping to keep our emails, bank accounts, and personal data secure from unauthorized access. By understanding how to break down numbers into their prime parts, cryptographers can build systems that are tough for anyone to crack, ensuring privacy in our digital world.